Let's take a look at the laws of logarithms. We're going to focus on logarithms as inverse of exponents. We're going to look at the addition law of logarithms, the subtraction law of logarithms. We're going to look at logarithms of exponents, the logarithm of 1, and logarithm of a number equal to the base. Now let's get started. So logarithms are seen as inverses of exponents. So with exponents, we have a situation where a to the power of x is equal to b. So when you write it as a logarithm, you have log. A is your base. Notice that you have a is your base here, is also your base for the exponent. B equal to x. So a is called the base of the logarithm, and b is the number whose logarithm needs to be evaluated. So now what we're going to do first is try to write these exponential expressions as logarithms. So what we're going to do is we write the log right here. We keep our basis right here, and then 64 comes over here equal to the exponent. Same here, we have our log. 1 over 5 is our base. Then 1 over 625 is the number, and the exponent is the result. Now we look at the addition law of logarithms. If we have log to base a of p plus log to base a of q, that is actually the same as log to base a of p multiplied by q. So important to remember that the addition law only applies when you have the same base. A is your base. So you have to have the same base for the addition law to apply. Now let's look at simplifying these logarithms here. So log to base 7 plus log to base 4, log of 7 plus log of 10, that's going to give us log of 7 times 4, which is log of 28. Also, one thing to take note of is if you have no base, just assume that the base is equal to 10. Now let's look at this right here. Log to base 4 of 9 plus log to base 4 of 10. That is going to be log to base 4 of 9 times 10, which is log to base 4 of 90. So you can see here that as long as the bases are equal, are the same, you can apply this addition law. Now let's look at the subtraction law. The only difference here is when we subtract, we divide p and q. So log to base a of p minus log to base a of q is the same as log to base a of p divided by q. So now let's look at this example. Simplify log 75 minus log 5. So that's going to give us log of 75 divided by 5, which is log of 15. Now we look here, simplify log to base 3 of 12 minus log to base 3 of 2. So we have the same base, so I'm going to write log with the base of 12 divided by 2, which is log to the base 3 of 6. So we look at the exponents. When you have an exponent on the number whose logarithm you're trying to determine, the rule states, or the law here states, that you would multiply log to base a of p by the exponent. So the exponent is right here, multiplied by log to base a of p. So let's apply that here. So 81, if we want to break this up, we can use the factor trees. We have 81. You have divide by 3, you get 27. You divide 27 by 3, and you get 9. You divide 9 by 3, you get 3, and then So log of 81 is the same as log of 3 to the power of 4. So now what we're going to do is we're going to put the exponent on the left hand side and then log of 3. Now 125, we divide that by 5, we get 25, and then we divide that by 5 and we get 5. So log to base 3 of 125 is the same as log to base 3 of 5 to the power of 3, which we bring the exponent to the left hand side and then we write the rest of the log. So that's how you deal with expressing the logarithm of numbers that can be written as exponents. So log to base a of 1 equal to 0. It doesn't matter what a is, as long as you have a 1 here, you're going to get a 0. So log of 1, this is going to give you a 0. Log to base 3 of 1/2 plus log to base 3 of 2. Okay, so let's apply our original addition law. So it's going to be log to base 3 of 1/2 multiplied by 2. So this is going to be log to base 3 of 1, which will give us 0. And finally, log to base a of a. So here it's saying that if the base and the number whose logarithm you're trying to look for or determine are the same, you're going to have 1. So log of 10, remember that log without a number in the base assumes that it's 10 because we're counting base 10. And then, so we have 10 here and 10 here, so this is going to be 1. Now let's look at this. We're going to apply addition. So log to base 3 of 3 over 2 multiplied by 2. So log to base 3 of 6 over 2, which is log to base 3 of 3. The base and the number whose logarithm we're looking for are the same number, so this is just going to give us the number 1. So these are the laws of logarithms that you would need when you deal with logarithmic equations, but this is just to introduce the laws and how you can apply them.